Inspire Me seminar today. Wonderful, beautiful Friday in February here in Boise, Idaho. We do have a special guest here with a group you can see behind me, the Industrial Assessment Center students. And I guess just to start off with, let's make sure, if you haven't signed up, I know there's maybe some extra credit opportunities, make sure you get your name on here. If you haven't, just keep handing it to the next person if you've already signed up. So. One other thing, in 2 weeks, correct? So today's 14th, and February the 28th, we are scheduling a large seminar on the new curriculum rollout. So 2 weeks from today, and it will be in Rook 110, the big one over there. I don't know, there might be 5 people, but hopefully it'll be like 100 people there. So, and we will be talking about the new curriculum. So I encourage everyone to come and be a part of that seminar as well, if you have any interest or any curiosity about what that's going to look like starting next fall. All right, so we have the Industrial Assessment Center group here. So the Industrial Assessment Center, also known as the IAC, is a Department of Energy sponsored program that provides eligible small and medium-sized manufacturers with in-depth energy assessment of a plant site, including facilities, services, and manufacturing operations at no cost. So it's free, just like the seminar is free. Right? And so the director of this program is one of the faculty here in Mechanical and Biomedical Engineering, Dr. Krishna Pakala, who I'm sure most of you already know. I could go through and say that he's an instructor in our Thermal Fluid Sciences curriculum, but also runs the Living and Learning community here for the freshman students, but also is the director of the Industrial Assessment Center. So he's got a lot of stuff going on, and we're excited to hear what you have going on with the IC. So thanks, thank you.
I had a couple of sentences in the whole presentation, and Don already stole the thunder. He already read what the IAC was. But anyway, you got the point. So I'm Krishna, I'm a faculty member in mechanical engineering. So I should give credit to Dr. John Gardner. He was the first one to start this center at Boise State several years ago. We are in the second 5-year cycle. We have 1 more year for this project, and ideally we want to apply for 1 more cycle of it. So on this lovely day, right? You get the point. The reason we are here is, 1, to relay information, which you get at these seminars, but most importantly, we want to recruit many of you into our program and see how you can see the benefit of this and also add value to the strong group that we already have. Some of these people will graduate, which is a good thing, but then we also want to kind of have you come in maybe as early as March, and we'll help you train and set up with the center. So energy efficiency is important, right? You can't deny that. Just as an example, in the industries that we look at, process heating is about 36% of the energy cost. And some of the techniques and tools that we employ when we do these visits will save the manufacturing industry about 5 to 15%. That's a big, substantial amount of savings, right? So the main focus of our center is to visit these industries and look for opportunities where we can recommend energy savings. So what is the IAC? We are not working alone in this world. We have several other universities who have centers across the US, so about 31 centers. We are kind of unique in the sense that we partner with people, and we partner with University of Idaho, who are our satellite campus. We do the assessments together, where they take some load off us and we do some as well. So we look at, like I said, energy utilization of the manufacturing facilities, and then what we can do to save money and recommend some savings. With whom do we work? We had to change the title based on the expert English person here, Dr. Gardner. So it's a wide variety of industries. When we say US manufacturers, it could be dairies, breweries, which is not on the list. Was it part of the exercise? Was it part of the,
yes.
Yeah, so we go to a lot of these unique facilities, and then you can see we cover about 150-mile radius in terms of where we go. And we partner sometimes with the University of Utah, which is something that we want to do in the summer, where we do it together in in terms of the visits. So you can see we are helping these small and medium scale manufacturing industries. Later on you will know how we say small and medium. And also the most important thing why DOE or Department of Energy is interested is to train you guys, you all, to be interested in these careers. And most of our students who have gone through this program are working in those industries. So it is a really good opportunity for you to benefit.
So I'm Ryan Montrose, I'm a graduate student, and I'm also the technical lead. And I wanted to give you guys a few statistics that help present what we've accomplished over the years. So in conjunction with Boise State and Idaho State University, we've written over 134 reports in total. And in those reports, we've recommended savings of over 64 million kilowatt hours, which, just to put it in perspective, that could run almost 9,000 homes for an entire year. It's a pretty big number, and we're pretty proud of that. And going on, we've recommended savings of almost 70,000 kilowatts per year, or per month per year. And then also, we've recommended savings of over 300,000 and then BTUs of natural gas. And then to put that into perspective, it can fill almost 4,000 Olympic-sized swimming pools, which is a substantial amount. And this is real savings that the company can save. They're helping take down or be more efficient.
All right. I'm Andrea Eborn. I am the manager of client relations in the group. And so my job is to go out and get clients and then also facilitate, like organize and all that. Part of this job requires me to get creative with finding clients, and some of the more fun methods I have found for doing that are like just going on Google Maps and looking around Boise and looking for or typing in manufacturers, and then you look at the satellite view and you can kind of get a clue about what sort of equipment they use. And you can see if they have large energy consuming equipment, like big HVAC units or refrigeration systems, that sort of thing. Another thing is I've gotten in touch with Southwest Idaho Manufacturers Alliance and gotten our name put in the newsletter that they have, and so that's just, it's fun to get creative and try to think of ways to meet, because cold calling is great, but it's really hard to talk to the person you need to talk to by a cold calling. They get calls all day. So you have to figure out a way to talk to the decision maker. And then also when you connect with them, you have to be honest about the process. Yes, it is a free report, and we do offer energy savings, but there are requirements from them, time, information, that sort of thing. And then we also have to verify their eligibility. There are requirements for the businesses. They have to be within a certain range for energy costs, and then there's a max sales and employees. And we have gone outside of that criteria in the past, and it's always come back to bite us in the butt. Okay, you guys agree, right? Too small, and we don't have enough to recommend because there's just not as much opportunity for savings. And then too big, we just get overwhelmed. They also can't have an in-house professional, which we went to one place and the guy taught us a lot, but there wasn't a lot of value we could add. But we learned a lot on that visit. And then it's also important to set that date, get that commitment. So some skills that I've gained in this are just sales skills, which are important no matter where you're working. Even if you're just doing research or trying to start your own business, you really have to be able to sell your ideas or get grant funding or investor funding, that sort of thing. And then we, as a whole, get to create partnerships with businesses. You get to meet leaders in the industry in places that you could eventually want to work. So that's awesome. That's an opportunity we all have. And then the best part about this is the product I'm selling is awesome. I really believe in what we do. We have a great team, great mentors. The product is free. It's catered to the facility, and it's a partnership. We learn and they get this report, and so it's mutually beneficial.
I'm Rob Connor, undergraduate research assistant, and I'm going to talk about the tour. The tour is one of the most important parts of what we do. It sets the tone of how everything's going to go for the report. And we go there to collect data, establish a good relationship with the client, and to learn for ourselves about their processes and what's going on there. So every visit starts in the morning. If we got to drive far, it's earlier. If we don't have to drive that far, it's still early. But we have to prepare all the equipment and account for it, and make sure we all know where we're going, because sometimes we take more than one vehicle. We usually arrive at about 8:30 or 9. We have a pre-tour meeting with the clients. We meet in their office. You go through our introductions. The plant manager will tell us the plant history, the history of the whole company. Usually it's surprising how much detail they go into. And we establish boundaries with the client. Where can we go? What can we not do? Can we take pictures? What data do you not want us to know? And things like that. And one of the biggest benefits for me and everybody here is this really helps you to learn to present yourself professionally. And important things we always need to remember for every pre-tour meeting is to, you want to request your data as early as possible while you're there in the morning, because we're going to be there 4 or 5 more hours, and that gives them time to pull it up for us. And we need that data to know how much energy they're using now, like their utility bills, what equipment they have that's using that energy, and every place seems to have something different, but it all comes together to help. Once that meeting's over, everybody makes sure their safety equipment's on, and the plant manager or somebody from management will start taking us around the facility, and we all begin to fill our roles. Before the assessment, somebody will say, I'm going to look at air compressors, somebody will look at lighting, and you tend to branch out from what you're supposed to do, but you need to have at least one person that concentrates on a certain type of energy. The longer you work there, the more you start developing, just a feel for where is energy being lost, what's using it, what types of energy like propane, gas, electric, even the water use. And so you just, look around, take notes, pictures of everything you see. And you also become very familiar with the boiler systems. That's the heart of most industrial processes. I've been surprised. There's only been one facility we went to that doesn't have a boiler. And even if you can save them a little bit of money with the boiler system, they're running all the time, they use a lot of energy, and it saves them a lot of money. Keep your eyes up. There's always a guy that's supposed to keep track of lighting, but everybody kind of ends up contributing to that. And when you develop eyes of an assessor, you see like the insulation on the ceiling there, the chillers on the ceiling, the lights. These are not LED, those are not LED, and you just start thinking in those terms. And you get to go on the roof, which I was like, what's their HVAC? These are some stills from the dairy, and sometimes they have solar panels on the roof, and you see usually the one time we saw those, they weren't actually doing anything. And most of your assessment data is going to come from nameplates on equipment, particularly motors, so we always take pictures of these and another picture to remember the setting of where it was. And these give you just a wealth of information. Like this one here, these are ideal versions of a nameplate where they give you the horsepower of the motor, how many volts it is, how many amps, 3-phase, 60 hertz, the efficiency, power factor. These help a lot when you're assessing how much power you're using. And sometimes they look like this. And that's when you realize how important they are, because you just have to start making assumptions and going through equations about how much it theoretically would be used. You get to see a lot of neat things in facilities, these through some processing plants, and it's just always surprising about processes never are quite what you think they'll be. And they've always thought of things you'd never think of unless you had to, and they come up with some neat stuff. These are just some more highlights of interesting pipelines and hand sorting that companies do sometimes with different technologies. And once lunchtime comes along, we all get together back in the meeting without the management, and we talk to each other. What energy can we save them? What data do we need to accumulate? How were we impressed by what they were doing? Usually most places already have some energy efficiency things in place, but so we like to commend them on that and say, we like this, but you need to do this, and that's where the improvements come in. Then the client comes in once we're done with lunch, or sometimes they end up sharing lunch with us. And we commend them for what they're doing right. We describe the areas that could use improvement, and we solidify our data. Like, is it okay if we go put a data logger here? Can we go in this room, get data from that? And is there any data you haven't thought of that you have available? Then we wrap it up. We call the loggers on the equipment. We split up and we tour the areas of interest. This is when we're not a team anymore. We just kind of go where we need to for each of our own tasks. We converse with the client about any remaining questions or issues they might have, and we be sure to leave with a good handshake. And then sometimes we take a picture.
My name is Matt Walsh. I'm also undergraduate research assistant here, and I want to talk about the equipment that we use. So as Rob mentioned, when we go on these tours, we're looking around at all their major equipment and looking for what is consuming a lot of energy. And then in the meeting, during lunch, we'll discuss what we want to know more about. We might have a nameplate of something, but we don't actually know if it's turning on or off. We want to know exactly what it's doing. So here's some of the tools that we use. One of the most common tools is going to be a data logger. We hook it up usually to a current transformer, which allows us to monitor the amount of current and power that certain devices are using. A lot of the time we'll get air compressors, dryers, just any motor that's connected to a fan or a belt drive. Another thing that we like to use is our sonic air leak detector. This proves to be one of the most, biggest savings of ARs, or sorry, of recommendations that we like to recommend to them. Since basically every facility has some sort of air compressor, they have pipes running across their facility. These pipes do wear out, seals wear out, and there are leaks. And this is a device that we can test ultrasonic frequencies so that we know how many leaks they might have, an estimate of them, and how big they are. Saving lots of money. Yeah. And then another device we have is an infrared camera. This device allows us to look at a room or a motor and see what the temperature distribution of it is. Some of the most common things we like to look at are devices called steam traps, which basically are very good at conserving heat in a pipe. And we can take a look at it with the infrared camera. For example, this steam trap up here is not functioning properly because it's not producing any of the heat. It's hot the entire way through, so we can see if there's something wrong there. We can also take a look at large warehouses and see temperature gradients from the ceiling to the floor, because a lot of facilities, if they don't have destratification fans, there's a lot of heat in the ceiling and it's cold on the bottom, and that results in more load on the cooling and heating systems. So that's a great thing we can look at, and just various other things. These are really helpful at knowing, giving us temperature values that we can use in our calculations, and any other real measurements that we need to take. Next slide. And then one of the biggest things about these trips is safety. These are our manufacturing facilities. They have a lot of big equipment. They have forklifts. They have slippery floors. We always have safety equipment that we bring on the trip. That includes hard hat, glasses, ear protection, high visibility vests, so forklifts and other equipment people using equipment can see us. Non-slip shoes. And earplugs, because oftentimes these facilities are very, very loud.
Some of the common recommendations we do in these facilities are actually quite simple calculations for people who first started working for the IAC. They're great recommendations that can be implemented to most facilities. And a lot of the times, they're simple things that they're just burning through money and they don't realize that they are. So one of them is putting a VFD, or a variable frequency drive, on like an air compressor or a motor or something that doesn't always have to be maxed out using power. So what VFD kind of does is it changes the frequency and the voltage coming in to just give a nice smooth demand of power to a compressor rather than it ramping up and then going down, ramping up and going down. It actually can improve also a little bit of the lifespan of the compressor itself. Other ways of saving efficiencies is notched V-belts versus solid V-belt drives. There's usually about a 5% efficiency increase in just putting a belt on, reducing friction and drag, It saves a lot of stuff. And then, you know, simple things going from switching over to LEDs, putting on occupancy sensors in rooms when people leave the room. You don't need to leave the light on. You'd be surprised how much money you can actually save, about $5,400 a year on average, from just having the lights turn off all by themselves. Temperature setbacks, when no one's working in the facility, we often recommend saying, hey, maybe don't cool a room down to 72 degrees while it's hot outside, because no one's in there enjoying that temperature, so there's no reason to pump that energy in there, or remove the heat out and use that energy for that. And then also increasing to high efficiency motors. A lot of the facilities we go to here in Idaho were built many years ago and still have equipment that they've had for many years. Technology since then has gotten way better, and we have high efficiency motors that went from 87% to 92% or 96%, depending on the size of the motor and the technology available. And so these are just a few of the ARs that we'd expect for everyone to become familiar with if you do join our team, and they're a great way to actually apply a lot of what we've learned in our thermo, heat transfer, and fluid system classes.
So I'm Jason, I'm one of our senior undergraduate research people. Stepping off of Mateo's kind of broader thing, I chose a specific recommendation that I would hope would kind of demonstrate how the complex systems that we can see in a facility are not all that bad, and using just the skills that you're learning right now through your classes, you can break them apart into a lot more manageable chunks. So you have a diagram of an example boiler room, which is rather messy with pipes going every which way and a whole bunch of things that do stuff that's not always apparent. But one of the reasons that we really like to look at boilers is anytime they show up, they always represent several recommendations that are very reliable about producing savings. And whenever a facility has a boiler, it usually represents the sole consumer, or at least the vast majority of the natural gas that they're using. Something that this picture doesn't bring across very well is how noisy and how hot these rooms are when you're actually in them and they're running. But that heat is where we like to work. That heat is just energy. If we'll go to the next slide, most of it is actually leaving through the exhaust of a boiler. It's just being vented out. It's 350 degree to 500 degree air just being completely lost. And the thing is, with the boiler, we have the perfect place to put it. You need to pass the water into the boiler to turn it into steam and make something out of it. And if you'll see, we've already kind of transitioned to something you've seen in thermo or maybe heat transfer. You just have heat in one thing and you're going to put it somewhere else to make it do something useful for you. So already we took that nasty picture and we broke it down to that, which is familiar, which is nice. So this is where we kind of differ from, a problem that you'd see in a textbook. We actually have to go get the data for this, which can kind of be a challenge sometimes, but it allows for a lot of creativity in getting the stuff we need to actually run this, which always comes a little bit weird, so I left off all the math for this. Kind of just looking at our history, we can estimate about a 5% increase in boiler efficiency just from introducing an economizer, which is just a heat exchanger, which doesn't seem like much, but for example, we looked at an 800 horsepower natural gas boiler that was only operating 12 hours a day or just half of the year. And just that 5% saved 5,000 MMBTU or million BTU, which if we offset the cost of the natural gas that's fueling this boiler, that's over $25,000, which is usually enough to pay for the equipment, its installation, and a few other things to boot.
And after we've collected our data at the site, we come back, we all have our own roles on the team. We split up and we start writing the report. The first section of our report is going to be our basics section. Each person will write their own section, and then we'll proofread with each other and collaborate if we have any questions. We go through best practices of the client, what they're doing right. We want to recognize that, yes, they are already doing it. It improves client relations, and it's not just us telling them what they should do. We look at their utility bills. This is one of the unique experiences I've seen, actually going through these utility bills and calculating what they mean. It's a very valuable experience. We can create a graph of the entire year, or even 2 years if they give us the data, of how they're consuming energy, where, and that leads into the next one, major equipment and energy usage, where this energy is being used. What systems are using this allows us to calculate in our recommendations how much savings they could potentially get. And we also get to learn about their process description. We go to a lot of different manufacturers. I've learned how French fries are made, how cardboard boxes are made, how milk is produced. All this cool stuff that you normally wouldn't expect to learn, you get to learn in this position. And then after we have that section done, we start writing up these recommendations. This is stuff Jason's talking about. We each get 1 or 2, sometimes 3 recommendations that we have to research about and write and calculate. This is also a big collaborative piece with our other team members. One of the big things is we strive to have a payback period where the savings will equal the implementation costs of less than 5 years. A lot of businesses don't look for investments that don't pay themselves back over 5 years, or sometimes even 2 years. So we really want to get these manageable size for these companies so that this is a realistic option for them to implement. And we have 2 categories, the assessment recommendations, which do make it under the 5-year period, and then other energy efficiency measures. These are ones that we think are really cool, but they do have a long payback period, and if they don't have funding for it immediately, they're probably not a viable option. Some of these typically include solar, especially here in Idaho. A lot of companies ask about that. Can we just put solar panels on our roof? Due to the cheap electricity rates here in Idaho, it's usually not a viable option. It takes them about 15 years to actually pay themselves out, so they're not super great. However, in other places that have high electricity costs, they could be viable. Another one that we've ran into a lot as well is a biodigester. That sounds really cool for a lot of food processing plants that have a lot of food waste. They can just put it into a biodigester, produce methane and other gases that they can use. But those do require a lot of land, and they don't pay themselves back. But we still include them in the report because they're cool, and we like to share these innovative or unique opportunities that they could potentially look into if, say, they get a grant or some sort of funding.
So diversity doesn't really come up in this role, on this team. This team is great. I've never felt unincluded, but obviously I'm the only woman. So the IAC is looking to diversify the team. So they have this wonderful program. It's called Women in Energy Efficiency. They've paired me with an energy engineer in Boise, and she's just been my mentor. She's been great. They have that as part of the program, and I really appreciate it. So yes.
Sweet. I'm Elias. I'm also a senior mechanical engineer with the IAC. I'm going to talk about more of like the experiences that you gain as a student within the IAC. The big things that have stood out for me is that in the classroom you just get to see your control volume around a big system. You don't actually get to see all the pieces of what Jason was talking about with the boiler. You get to see the boiler and all the other minute features of it that can be changed to make it more efficient or to make it just a greater opportunity for growth and for energy efficiency. Another thing is we get the ability to have like a professional demeanor with our clients. You can't just go in there. You have to have a certain bar that has to be set to show that you are a professional in the field, to be able to convey your ideas, be it through email, be it through a conversation. Just bring your best personality and best person to show to these companies who don't really know who we are, that we are here for them at the end of the day. With this, we do weekly presentations with the IAC as a team, along with presentations for the clients after the 2-month period. We do gain a lot of these presentation skills, from presenting our reports to presenting other energy efficiency measures that we personally find interesting. Other things are technical writing. degree plan of mechanical engineers technical writing is a class, and well, I always wondered why. Why do I take this class? It doesn't make sense. And then once I joined the IAC, it made total sense from writing those basics where it is a lot of professional technical verbiage to formatting a AR correctly so that it does make sense and that it does look like it is crafted and not just thrown together last minute. That has been a really beneficial thing for me, both for my resume writing and for jobs in the future, to have that ability, since a lot of employers are looking for someone who is well versed in technical writing. Along with that, the IAC does offer a certificate that would, as you see in the top corner right there, one of our past members, CAES, got the certificate. There's a couple qualifications that have to come with it, but as a whole, it's a great resume filler showing that you were dedicated to a craft for at least a year and did like safety or some of the requirements of holding the safety position, being the team lead, so the main contact between the team and the client themselves, just having those skills that then can help you down the road of finding a job. Also, 60% of IAC students do go into the energy related field. When I joined, I had no idea this was a path that you could take, and now I am looking at a lot of energy efficiency roles for careers to come. On top of this, there's a lot of learning and research, since at the end of the day we are students. We are in a research position. This isn't a full-time job, even though in the summer it can look like that. So we do value your student duties first, of if you're behind with an AR or whatever that might be with a due date. We totally understand that we are students and that we have a heat transfer Pacala test coming up next Wednesday or whatever that looks like that we need to work around, so we kind of help each other out when things like that do come up. You do get paid. It is not a great source of income, but it is paid for work, so it does help you in some aspects, which is always beneficial to have a research position that does pay you to do things that are interesting. You do get to understand energy calculations, which do come up a little bit down the road, more on the financial side in thermal fluid systems, depending on who you take it with. There is a finance unit of calculating a simple payback, calculating interest and whatever that might look like, so it does help you with understanding those terms. And just, as I said earlier, just being able to view literal systems instead of looking at it as a cardboard cutout problem of, you have this input with this output. You actually get to see what that input is, see what the output is, and see the in-between as a whole.
Okay, so one of the things that we forgot to mention is the report that we do and the sites we visit is all confidential. These students don't share it with anybody, and we report the data to the client and to DOE. They have a field management office at Rutgers University. Those who will have all the data, but then the actual website that is open to the public only categorizes them into SIG codes, manufacturing codes, and the data is not tied back to the industries. And also the other important thing is we are in the business of idea generation. We don't actually make sure they are implemented, but we would love to see if they're implemented. So we do a phone call with the industry within a year and see whether they implemented any of those and report it back to DOE so that we can see how much of it getting done. I think the most important thing is there is a lot of learning that happens. Most of these folks joined together as one group, and they themselves can see how much growth has happened. And you will learn those things. But at the same time, you need to have some basic understanding which you will get in thermodynamics, fluid mechanics, and heat transfer. And at the core end of this, we kind of look at everything simpler and then scale it up with all the data that we have in terms of previous recommendation reports. We can look those up, but the basic understanding comes from how well you do in the thermo, fluids, and heat transfer, right? So we do look at open and closed systems, and we recognize that some of these things right now, like compressors, motors, and pumps, they could be a simple energy balance equation, but that's what we also end up doing. We just add more value in terms of money and cost savings like that. Okay. Did we convince you it is a good job so far? Okay. So we do have openings because some of these folks are going to move on and pursue other careers. So the job currently is open on the Boise State handshake system. I think we got few applications so far. We would love to see more, and we do pay you. It starts at $11 an hour. And the applications close end of this month. And we will immediately, as soon as that closes, we will start scheduling interviews with folks the first week of March, because we have a industry visit scheduled on March 6th. So ideally, we would like to do in the first couple of days, get you, interviewed, and then see whether we can offer the job, and then immediately get you on the team and get you trained. And in terms of the application materials, really simple. A cover letter, 1 page. We are looking for what skills and education that can contribute to the IAC. You kind of know what skill set we are looking for. And then what do you want to get out of it? That's very important. Like, what are you looking for in this? And then obviously you should have your resume. If you have not spoken to Leandra till now, then you're missing out. She can help you if you want to tailor it to our job. No more than 2 pages. If you can make it into 1, that would be awesome. We look for 3 references. Anybody that can vouch for you in terms of the skills that you're articulating in your cover letter and your resume. It could be, it will include me and John as well if you have taken classes with us, but we prefer if like John or somebody else it doesn't have to be from thermal fluid sciences. Anybody who can, vouch for your academic prowess would be good. And the other thing is, we're not looking for like top A students or anything. Anybody who has the inclination to, get their hands dirty and then trying to learn is what I think are really generally successful in this. And we have seen students who tend to do that, then see the value in going to class and doing the homework and everything, and they perform better in the classes too. Okay, so you have all those cool things happening, and we probably are looking for maybe 3 or 4 in terms of positions. And you can see the kind of training that happens is not like one job. They all get trained into different aspects of the job. She's our client relations manager. We have a graduate student, Ryan, who is kind of the manager or the technical lead of the team. Me and John show up to meetings for the cookies and cupcakes they bring to the meetings, right? And then also you can see like they all have this community, and they're really applying all the skills they're learning and also giving back to Idaho and beyond. Okay.
Now we're going to take turns to sing
Okay,
what we chose.
all right, I'll start. Why did I choose? Few years ago, John approached me and said, I think you might be interested in this. So I said, okay, I'll check it out. So he invited me for a tour, and then I really loved how it's almost like a gang, and they have a mission, and they perform it like really well. And I was really fascinated by the whole experience that these students have been going through, and then I thought that it has a lot of relevance to the classes that we teach. And then fortunately he agreed to put me on the team, and then later on I realized he said you should do this as a full-time job. So I really enjoy learning with the students as well. There are things that me and John also have to learn in terms of how these actually are advancing, and then John will be like our senior technical lead on these, and then we kind of, whenever we don't know information, we don't fake it. No fake news here. We have documents that can help us relate. DOE has a website which lists a lot of energy efficiency tools and measures that we can look up as well. So there's a lot of reliable information. So it helps me kind of get these students in there, and also gives me a chance to mentor them and also learn. So that's why I chose IAC.
Dr. Garner also gave me this opportunity along with graduate research through him. It's a great position. I learned a lot. I'm getting really good at technical writing.
I joined because it felt like it turned out to be a broad internship, meaning you get exposure to a lot of different industries. I was kind of worried about getting pigeonholed if I took a certain internship into a certain thing, and even beyond energy efficiency, you learn a lot about manufacturing, energy generation, and just the way a lot of processes flow. You also learn to work with other engineers, both within the IAC, and you meet a lot of professional engineers out there that you have to talk to them and just kind of get a feel for how that works. It's been really good.
Yeah, for me, I was kind of in your guys' shoes last year. I didn't know anything about the energy sector, that it was something. And then once someone gave a presentation in front of my heat transfer class, I said, that would be like an interesting opportunity. It does kind of parallel to an internship. It's year-round, so you don't stop for a summer. You keep going through the summer. Just having that opportunity to apply the skills that I learned and to just take steps towards an internship, since I didn't have anything lined up my summer last year, was just an awesome opportunity, and now has opened my eyes to a career path that I didn't ever think was available for me.
I came in as I'm really interested in the clean energy transition, and obviously energy efficiency is a huge part of that, so I came into this team with that in mind. I think the best thing about this team in particular is that when you go on these visits, you're overwhelmed, honestly, when you get there, because there's so much going on, and afterwards we all talk about it, and we all in the same boat. We're all kind of overwhelmed, and we're like, how are we, like our first visit, we're like, how are we gonna do this? But it's so fun to just separate the duties, and then just like when they say, how do you eat an elephant one bite at a time, like we all just separate our duties and we all help each other, and so that's really fun, because think about going into the workforce with no experience and feeling overwhelmed and not having this support group. How horrible that would have been. It's so great that we have that opportunity to get that over with now while we have a great support system.
Biggest reason I joined, again, just like Elias, we've been same classes and everything throughout years being here. I didn't know what I wanted to do. I knew I wanted to be a mechanical engineer. I started freshman year going, maybe I'll do something in robotics, maybe I'll do something cars, some planes and rockets, maybe something really cool, Just as the years went by, I still kind of had an unknown feeling of, still don't know what I want to do when I grow up, And honestly, when this was presented to me in our fluids class, it was, hey, here's a great opportunity to go to all these different industries and be exposed to all different types of people, and you can, you go in, you talk, say, hey, what's your job? Oh, I do this. I didn't even think that was a job. But that sounds neat, and so you get exposed to all sorts of types of people, and then it does open up a lot of doors, because you network, you keep the client relations. A lot of the times they've even said, hey, we've got, job openings here and there. You're not guaranteed the job, but hey, I know you now, you can definitely apply. So it's for me, and then along with Andrea, it's knowing that I'm doing a lot of good in the world right now, and helping out these smaller companies save money and boost their own private economy.
So I had actually learned from this position from Dr. McCullough in this heat transfer class, and it was at a perfect time that I had actually started looking at my coursework through thermo, fluids, and heat transfer. I'm like, man, this stuff's pretty cool. It would be nice if I could make a living out of that. So it was pretty good timing, and it was also great for me because I'm one of those nerds that's prone to getting his head stuck in the homework and not really seeing the bigger picture of what's going on. So that helped me break out of that idea and say, well, where can this go in the future? And so it was just kind of an excellent opportunity to get the experience in something I'd like to do and get paid for it too.
Yeah, and when I joined the IAC, I was interested in energy, but I didn't know what, energy. I wanted to go into the energy field, but didn't know what I wanted to do. And I remember the first visit, I was walking with Dr. Gardner, and I was looking at all these pipes and these huge systems, and I was overwhelmed. And I'm like, I don't know anything about this. And then Dr. Gardner just started pointing out, no, that's a compressor, these are the inlet, this is the outlet. And he started breaking things down to manual pieces for me, and I learned a lot about what systems do what and how to analyze them, kind of investigate, and take something really complex and put it down to a manageable size.
Join us.
Let me just add one more thing. So this program is funded by the U.S. Department of Energy, and it's been around for a long time. It actually started before we had a Department of Energy, so this is when Carter was president. So it's been around for over 40 years. And it is really well respected in the energy field in general, but also within higher education. So, you saw the number of engineering schools, and they're always in an engineering school across the country that have these. The reason I chose this was because I wanted to bring that that prestige, frankly, to Boise State. And so we've been doing this for a while, and we want to keep doing it for a real long time. The other point I make is that a lot of our graduates want to find engineering employment in the valley, in the area. These energy-related jobs are much more common than most. Okay, I wouldn't say it's the most common engineering job in the valley, but this is where your chances of getting employment are higher than, say, if you want to build airplanes. You're not going to do that in Boise. But the energy field, you can't offshore these jobs, right? These are ones that are always going to be.
Yeah, questions, comments?
Are you guys all mechanical?
I'm materials.
You're materials. What about you?
Sometimes we'll have, electrical, we have civil. We didn't talk much about, we sometimes do wastewater issues too, that falls into the category, so we'd love to have some civil engineers for that. And, we do a lot of work with things like power factor and electric motors, so electrical engineers, we have to work our way through it the hard way every time.
Yeah, even computer science in the future, that could be a big portion with cybersecurity awareness and actual big push, so that is another. Yes.
Does your whole team go on the site visits every time?
For the most part.
Yeah,
Yeah?
if you're available, you can go.
Yeah. Sometimes we might want a smaller team or a bigger team, depending on how big the factory is. If it's going to be a smaller visit, we might pare it down. Yeah.
Yes.
Is there a biodigester operating in Idaho that you know of?
Dairy Gold, I think, has one.
In Twin Falls?
Dairy Gold or?
There's a really big one right off I-84, right up the connector, right by St. Alphonsus.
I can't remember what it was.
But they torch the gas, they don't do anything.
Does the city of Boise have one? Don't they?
Yeah, they've got one too.
Yeah.
They use that gas for boilers. The food processors have to have a biodigester because they can't let the methane go out. They've got to digest it, whether they harvest it and do anything with it.
Any questions?
You all know how to apply? Okay. In 1 hour, I should see a lot of applications. Otherwise, I'm going to email you all. You have the list.
Yeah, it's always a good idea.
Yeah. I mean, one thing you probably didn't notice is they practice this presentation like once, and you can see how well they have done. And it's very tough to give these sort of presentations. So, there itself, you should really trust that you should join IAC.
Did you get a free T-shirt?
Yeah.
Oh yeah, get this T-shirt or that kind of shirt.
Yeah, travel too.
I didn't get the memo this morning, so.
Yes.
So what's been the most challenging visit you guys have done in the last year or so?
I think
We can't say the place. Probably the biggest one we went to. Do you
Yeah,
disagree?
Tell the product, you can tell the
Potato bag.
Potatoes, huge. And that was the one where they had the energy efficiency guy. Like, he was the engineer, but he was like a bulldog with Idaho Power and like getting his incentives and like taking full advantage of their programs.
Yeah, he just invited us there to show off and be like,
Yeah.
I don't actually need you guys.
But it was still an interesting opportunity because even though we got to go to this massive facility that had very state-of-the-art stuff, it was like, oh, that could be me in the future. I could be that energy guy on the site. So
Yeah, because he did mention, like, he can basically write his own ticket as far as income because he can show, I'm saving your company this much money, you should pay me
yeah.
this.
Yeah, he was like, oh yeah, I paid myself 3 times over this year.
Yeah, yeah.
It's from the amount savings.
Yeah.
What's the farthest place you've gone to?
I
Burley.
think Burley.
These guys at the Burley.
Oh.
Yeah.
The team has gone to
I've been
Alaska.
Kodiak.
Yeah.
Yeah, Alaska.
They got stuck there for another 3 days.
Was that the fish processing place?
Yeah, yeah. A lot of dead salmon.
Yeah.
Wait, the fish fry, why'd you go to Alaska?
So the Department of Energy wants to see a lot of coverage, and they don't have, the universities there don't have one of these centers. So the folks in Miami will go to Puerto Rico, the folks in San Francisco State University go to Hawaii. We go to last. Let's see if we can fix that. But, you know, some of it is that they don't get to see assessments very often, but also, you know, there's senators in Alaska that vote on Department of Energy budgets, and so we want to make sure that they can appreciate it too.
How often do you visit a new place? Like once a month? Or once a semester?
It's every
2 months.
60 days.
The summer is different though. We just have more time. We do every 2 months just because.
8 to 10 a year.
Okay, cool, yeah.
So during the summer, we'll sometimes double up and be writing 2 reports side by side, just so you can maximize hours during the summer. So you don't feel like you're limited to
You get to
15
spend
hours
night
a week.
early.
Yeah.
Yeah. I mean, it's nice. All the time, the hotel's paid for. They give you per diem, so you don't feel like you just left somewhere. You got to spend your own money on food because you don't have your own kitchen and stuff like that. So you are well taken care of as far as when it comes to travel.
Contractually, we do have to do about 20 per year, but we kind of split it between University of Idaho. That's where the number 8 to 10 is Boise State, rest of them can do it. And then the other cool thing that we started recently is we are having both of these teams also talk with each other once a month, or and then talk about what are they doing differently, streamlining the process. And we, John and I and the team at UFI, we also meet bi-weekly virtually and talk about what are things that we are observing, what do we do for the next grant, when do we apply, and things like that.
What is that 5-year cycle you talked about at the beginning?
So our grant, when we apply it, we get it for 5 years, and then each year is a commitment of doing about 20 site visits. And then our next year is our last year for the second cycle of the grant that we have, and then we have to reapply.
Yeah, so you get the whole program's recompeted every 5 years. So we broke into it about 10 years ago is when we wrote the proposal to break into it. They only brought in 40 universities that time, so must have been a good proposal. And once you're in it, it's a little bit easier, but you still have to take it.
Yeah, good.
All right,
Thank
any
you.
other questions?